Here's another factoring problem, but in this one we have a coefficient out front, so it becomes a little harder to factor. To get the first term, we multiply these first two spots. So in this case, we can't just multiply n and n, because that's n squared and we need 4n squared. So we're either going to need a 4n and an n, or two 2n's. And then to get the 9, it's the two last terms, and the only way to get 9 is 9 times 1. But we don't know if we want a 9 here, a 9 here, and a 1 here, or a 1 here. So, or you could have a 9 here, and a 1 here, or a 1 here, and a 9 here. So, we're just going to try it out. And if we put a 9 and a 1, we get our 4n squared. We get our 9. In the middle we have 2n times 1, which is 2n, and we have 9 times 2n, which is 18n. When you add those, you get plus 19n, and that's not, we need 13n. So you know that's not right. And then if we put a 9 here and a 1 here, we get our 4n squared, we get our 9, and then we have 4n times 1 is 4n, 9 times n is 9n, and 4n plus 9n is 13n. That's what we want. So our answer is 4n plus 9, n plus 1. Another problem. We have 6n squared plus 54n plus 120. And we know we're going to need to factor it, but we can see that we have a greatest common factor because 6 goes into all of these terms. So first we pull out a 6, and then 54 divided by 6 is 9, and then 120 divided by 6 is 20. And then we need to factor what's in the parentheses, so we still have the 6. And then we know to get n squared we need n and an n. And then to get the 20, we can have 20 times 1, 10 times 2, 4 times 5. So if we try these out, if we go with 20 and 1, we're going to have n squared plus 21n plus 20, and we need plus 9n, so that's not right. So then we try 10 and 2, it's n squared plus 12n plus 20, so that's not right. And then if we try 4 and 5, we have n squared, and then 5n plus 4n is 9n plus 20. So that gives us what we want, so our final answer is this, because we took out our greatest common factor and then factored the rest. So this is the solution.